Welcome back. This is lesson 7.9 journal. We are identifying equivalent expressions. I will be able to identify equivalent expressions by first simplifying each expression to its simplest form by distributing and then combining like terms. Vocabulary for this lesson: distributive property. Remember, that's the property that we used when we multiply something on the outside of parentheses to each term inside the parentheses. Factoring is when we pull something out. Equivalent expressions are equal to each other when simplified, and like terms are terms that have the same exact variable. It can be added or subtracted together. Alright, so here it says prove that three groups of 4 plus or x plus 4 and x plus 14 plus 2x minus 2 are equivalent by modeling both expressions. Alright, so this one means three groups, so I'm going to make three groups. 1, 2, 3. In each group, there's an x and 4 ones. So x, 4 ones. X, 4 ones. X, and 4 ones. Okay, there's a model of three groups of x plus 4. So this one, we start with an x. We're going to add 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then we add 2 more x's. And then we minus 2. So I'm going to take off this one, and I'm going to take off this one. Alright, two models of two differently written expressions. But it says prove that they are equivalent. How can I prove that they are equivalent? Well, in here I have an x for an x, an x for an x, and an x for an x. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ones. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ones. So this simplifies to 3 x's and 12 ones. This one also simplifies to 3 x's and 12 ones. So because of that, we know that they are equal to each other. Might have taken different paths to get there, but they are equal. So here it says simplify each expression and then determine which expressions are equivalent by matching them. So if I simplify this, I have like terms, so I can combine 13v's plus 7v's. So I'm going to put these together. And that's going to give me 20v's minus 4. I can do no more because v's and 4's are different from each other. Okay, this one right here, v plus v plus v plus 7 plus v, that is 4v's plus 7. Here I have to distribute, so this would be 6 times v, which would be 6v's, plus 6 times 1, which is 6. So this one is 6v plus 6, so nothing is equivalent yet. Okay, let's try this one. Let's distribute. 3 times 4v would give me 12v, plus 3 times 6 is 18. So far, nothing matches. This would be 4 times 5v, which will give me 20v, minus 4 times 1, which is 4. Okay, so those two are equivalent to each other. 8v plus 4 minus 4v. Okay, if I have 8v's and I minus 4v's, in the end of my story I'm going to have 4v's left. And then 4 plus 3, add my constants together, I get 7. Those are equivalent. So, these are not equivalent, but these are equivalent to each other here and here. Now, you couldn't just see that until you simplified it. So that's why it's really important to be able to simplify expressions so that you can figure out if things are equal to each other. Alright, down here it says, which of the following expressions are equivalent to 6m plus 6? So we're going to distribute and combine like terms and see which ones are equivalent. So this one, to simplify it, I want to distribute and just see how many m's I have and how many 1's. So I'm going to do 3 times m, which is going to give me 3m, plus 3 times 2, which gives me 6. That is as far as I can go. That is not equivalent. The m's are different. So this one is not equivalent. This one here, we have 3 times m, which would give me 3m. This gives me 3 times 2, which is 6. So once again, that is not equivalent to 3m plus 6. Here we have 2 times 3m, so that would give me 6m. But remember, we have to distribute to both terms. Minus 2 times 3, which is 6. Oh, I got 6m's and I have 6. However, you see this minus here? See this plus? Oh, those are not equivalent either. Alright, let's try this one. This one's a little bit more complicated. We have some distributing going on here. So 2 times 3 is 6m. We have to multiply before we can add or minus anything. So don't be trying to minus and add those yet. You have to do the multiplication first. Plus 2 times 10, which is 20. Minus 14. Now we can combine like terms, because now we're adding and subtracting. So I can combine this. 20 minus 14 is going to give me 6. So 6m plus 6. Now that we're done with it, those are equivalent. So I'm going to circle that one. That one is equivalent. Okay, let's try this one. 20 minus 6m minus 14. I can combine 20 minus 14, that gives me 6. But I'm still minusing 6m here. Is that equivalent? No, because 6 minus 6m is not the same as 6m plus 6. Not equivalent. Alright, combine like terms here. I have 10m plus 10 minus 4. Oh, 10 minus 4, I can do that. That would be equal to 6. And then 10m minus 4m would be equal to having 6m's. 6 plus 6m. Oh, because of the commutative property, we can switch those around, and you can see that those are exactly the same. So yes, these ones are equivalent. How about this one? 6 plus m plus m plus m plus m. How many m's are we adding? 1, 2, 3, 4, 5, 6 m's. So that would give me 6 plus a total of 6 m's in its simplified form. Once again, out of order, but because of the commutative property of addition, we can switch that order around. And we can see that these are equivalent. Let's try this one. 6 times 1 gives me 6, plus 6 times m. Commutative property, switch those around, and I can see that they are equivalent to each other. Last one. We have to distribute 1/2 times 12m. 1/2 of 12 is 6m, minus 1/2 of 12 is 6. I have 6m and I have 6. Problem is, there's a minus here. This is a plus. So these are not equivalent. Okay, I hope you can see how simplifying expressions can help you tell if they are equal to each other or not. Rate yourself on this concept, 0, 1, 2, 3, or 4. Take a picture and turn it in on Google Classroom.